This lesson is about friction. Now you're going to look at two types of friction, static friction and dynamic friction. And you're also going to learn how to calculate forces in situations where friction is happening. Now first, a review of the kind of forces that you come across when objects are in contact forces. This is a reaction force, or normal force as it's sometimes referred to, which is the action of a surface balancing out or responding to a push down. So here we have a reaction force up because weight is making this object push down. Just as a quick reminder, normal reaction forces are always perpendicular and so therefore are easy to identify with respect to the surface. Now there are two types of friction, static friction and kinetic friction. Static friction occurs when an object is just about to move but isn't moving. So imagine a really heavy shelf, you're pushing away at it, you're applying a force this way, and friction is acting but it's not moving, right? Now if you want to imagine, or if you want to conceptualize it in another way, if static friction did not exist, that means if this was a frictionless surface, then what would happen if you pushed this really hard? Well, the whole thing would just go flying, wouldn't it? So that idea of static friction limits the motion of the object. Okay, so once again, friction is always in opposition, right, to the way it should move had the force applied one out, right? So this is your force applied, and this is your frictional force that's trying to oppose it. Okay, so that is static friction. And here we have kinetic friction, which is the friction that acts when an object is moving, either accelerating as it says here, or even moving at constant speed. We would still consider that to be kinetic friction. So two types of friction, one when an object is about to move, and then secondly when it's moving but the surfaces are still touching. Now, what is friction? Friction happens because even at a microscopic level, even if an object looks really, really smooth, it's you'll find that surfaces are rough, are kind of uneven, and do interact with each other. So experiments show that the magnitude of the force of friction acting between two surfaces, so when you have these two surfaces interacting with each other, you actually find that it is proportional to the normal reaction. So depending on the push up of the surface up on the object, the greater that force of friction will become. Which kind of makes sense, because if this is really heavy and it pushes down, then the push back up, the reaction force, is also going to be huge, and therefore these two surfaces really dig into each other, and so therefore friction is greater. So we're now looking at a mathematical relationship, which we are going to examine in the lab. The force due to friction is proportional to the normal reaction, the reaction force. So what we have is a constant of proportionality. We have friction equals a constant of proportionality times r. And that constant of proportionality is called mu. No, that's not what cats do. Mu is a constant. And we have two, depending on the situation. We have, the constant, the coefficient, mu, the coefficient of static friction. Sometimes it's called limiting friction because it's limiting movement. And then you also have mu d, which is the coefficient of dynamic friction. And so we now have two relationships. We have a relationship for friction, which is equal to mu, the coefficient of friction, static friction, times r, and then mu, d, which is the coefficient of dynamic friction, times r. Important to note, the coefficient of friction is always less than 1, and for any two given surfaces, you always find that the coefficient of friction, static friction, is always greater than the coefficient of dynamic friction. Does that make sense? I hope so. So that's the basic theory. what friction is, the difference between kinetic friction and static friction, the difference between μs, the coefficient of static friction, and d, the coefficient of dynamic friction. Time to try some more applied things, like some questions.